Guys, welcome to YouTube channel Foundation JEE. Today's lecture is on numerical problem on a spherical mirror of reflection of light. This lecture is continuation of our last two lectures on reflection of light by plane mirror and a spherical mirror. So see the question here. 4 centimeter high object is placed at distance 16 centimeter from concave mirror. The image is real, inverted and 2 centimeter in size. Find focal length of mirror and position of image. Okay, so guys, for solving such type of problem you need to know some assumptions we made while solving the problem. The first assumption is always place object left side of mirror. Okay, so guys, in this question the mirror is concave. Okay, so see here, this one is a concave mirror. Okay, here polishing is inside and coating is outside or bulge part. Okay, now this one is a concave mirror. So what does mean by left hand side? So if this one is a pole, okay, and this is focus, or this one is a center of curvature, if we draw a line passing through all these 3 points, so this is known as principal axis. Okay, now so object shall be placed left side of mirror, means you have to put the object left side, means this side. Okay, so this one is a object. Okay, the second assumption is object is always perpendicular and erected on principal axis. Okay, so what does mean by this one? So see, this one is a principal axis or this one is a object. Okay, so it must make an angle of 90 degree, or other thing you see here, the head of this object or arrowhead is in top. Okay, so this is here erected position. Okay, now this one erected. Now see the assumption 3, image is always perpendicular, erected or inverted on principal axis. Okay, if in case of concave mirror object is between infinity and center of curvature, then image is inverted and real. Okay, so see how could you say this image in inverted? So you see the arrowhead is opposite to this object arrowhead. Okay, or it is downside with respect to principal axis. So we say this one is a inverted image. Okay, or what does mean by the erected? Suppose your object is here, then image formation will be on right side. Okay, so see here, the top of this object and top of this image is same, so we say this one is erected. Okay, one thing you notice guys, here I show the image, this one by dotted line, so it show the image is virtual. Okay, the fourth point, all distance is measured from pole of mirror. So what does mean by this one? Okay, so see here, this one is a pole. Okay, so which distance? The question say the object distance u, the image distance v, and focal length of the spherical mirror. Okay, so all shall be measured from this pole. Okay, suppose this object is here, so this distance is u. Okay, here now suppose here this one is image formation, then this one is v, or this one is f, so this is f. focal length. Okay, now the fifth point, mirror is placed on origin of x-axis and y-axis, that pole must be on origin of x and y-axis. So what does mean by this statement? Okay, so while making a distance measurement, you must always keep in mind that pole of the mirror must be coincide with the origin of x and y axis. See here, this one is origin, then pole must be at this point. Okay, or this one is x axis, or this one is y axis. Okay, now the sixth assumption is ray of light incident on mirror left to right. Okay, so always we place the object in left side here, then image must be come from left to here right. Okay, for all the spherical mirrors. Okay, so these are the six assumptions you must remember while solving the numerical problem based on spherical mirror. Okay, now guys, this one here is a mirror formula. Okay, so there is a relation between the object distance, image distance and focal length of the spherical mirror. So this one is 1 by V plus 1 by U equal to 1 by F. What does mean by magnification of image? So it says how many times the height of the image with respect to object height. See, this one is height of image, or this one is a height of object, or this one is equal to minus V image distance from pole divided by image distance from object. Okay, next we see how to solve such question. Okay, so guys, solving this question, what we do next, this one will be the x-axis or this one will be y-axis. Okay, as we read earlier that we place the pole of the mirror at the origin. So this one will be pole, or see, this one is a focus, or this one is a center of curvature of this mirror. Okay, now what information is given in question? A 4 centimeter high object. So here h0 is given equal to 4 centimeter. Sign is positive because we always placed object perpendicular to this principal axis. Okay, so this one is h0, or this one is a principal axis. Okay, now the second information is given here, at a distance of 16 centimeter from concave mirror. So distance between the pole and object is, guys, what? U will come here minus 16 centimeter. Why? Because guys, you know this one is x-axis, so this one is a positive number, or this one is also positive, and this one is a negative y dash axis, and this one is x dash axis, or this one is a negative number from origin to this side. So we always place the object left side here, left side, then you must be in negative number. Okay, the third information, the image is real, inverted and 2 centimeter in size. Okay, so inverted and real means we will show this one is perpendicular and solid line. Okay, so inverted will become of this one. So suppose this one is a x-axis here, or this is y-axis, this one is y-axis, so you can say this number will be negative. So here HE equal to minus 2 centimeter is given. Okay, and now the question is asking find the focal length of mirror and position of image. Means what will be the focal length and the distance between image and pole. Okay, it will give you position of image. So guys, here see we have this three information, so we can use this formula, magnification of image. So HE value will be what guys here? Minus 2 centimeter, or this is 4 centimeter, or C this is minus V, or U is minus 16 centimeter. Okay, so what you see, this negative sign cancel out, or this will come 1 by 2 into 16 centimeter, or this is equal to V. So this is minus 8 centimeter. Okay, so now you know U and know V. So if you place these two value in this equation mirror formula, then you will get the value of F. So we put here, see, so 1 by V equal to here minus 8 plus 1 by next one U value is given here minus 16, or this is will come 1 by F. Okay, now if we solve this one, so this is coming here minus 1 by 8 minus 1 by 16 equal to 1 by F. Okay, so this is 16 LCM, this is 1 into 2, or this is 1 into 1, or this is 1 by F. Okay, so you will solve this one, you will get here F equal to minus 16 by 3, or which is minus 5.33 centimeter. Okay, so what you see here, this distance is 5.33 centimeter. Okay, so the CP equal to R, or R equal to 2F. So if the 2 into 5.33, so this is coming 10.66 centimeter. So this one is 10.66 centimeter. Okay, now see, so object distance is 16 meter, so which is greater than this one 10.66, so object will be lie here. Okay, so this one, now the image distance is coming guys what here, see V value is coming minus 8. Okay, so this one is greater than 5.33 or less than this one, so it will come here like this one. So see, this proves the image of this object is inverted, okay, here and real. Okay, see, if you will make the image diagram, so we need a two ray of light. One ray of light is falling parallel to this principal axis and incident of this one. Okay, now when it is coming from infinity, then it must passing through the this focus. Okay, and other ray of light will pass through center of curvature and incident on this concave mirror, then reflected back, then see these 2 points cut here, then image formation is real. Why? Because two rays of light are cutting each other in actual manner. Okay, so now the concept of concave mirror clear to you. Now next see one question based on convex mirror. Okay, so guys, see one question based on convex mirror. A question is a 6 centimeter high object is placed at distance 36 centimeter from convex mirror. The image is virtual erected and 3 centimeter in size. Find focal length and position of image. Okay, so solving such type of question, you see this one is a convex mirror, or this one will be pole, this is focus, and this one will be guys center of curvature. Okay, so what information is given in question. Object height is here 6 centimeter. So if this one is a pole, so it will be erected and its height will be 6 centimeter. So h0 what 6 centimeter. Okay, now the second information is given. The distance between the object and the mirror is 36 centimeter. So you will come minus 36 centimeter because we placed always left side of the mirror. Okay, so here such way, so this one is well 36 centimeter. Why we have put the negative sign? Because we are using the coordinate geometry system where this one will be pole here like this one. So this is negative x axis. Okay, x dash axis. Okay, so you will be this one. Now the third information, the image is virtual and erected. Okay, so the virtual image will be formed and it will be erect. So here the image is formed virtual, so we show it dotted line, or erected, so it must lie above the principal axis. Okay, or erected, so top and top head will be same direction. Okay, now the other information is given here. The size of this image HE is given here 3 centimeter. Why? Because this one is a positive y axis. Okay, so we will use this formula, magnification of image, so we will get here the value of v. Okay, so v is image distance from the pole, so he is given 3 centimeter, or this one is given 6 centimeter, or minus v, u is given minus 36. Okay, so what will come? This is 1 or this is 2. So we will come, guys, here this negative sign cancel out. So 1 by 2 into 36 centimeter. So this is 1 or this is 18. Okay, so we will come 18 centimeter. Okay, what will be the focal length? So we put this value v and u in this equation, so you will get the f. So 1 by v is coming 18, or this one is coming 1 by minus 36, or this is 1 by f. So when you solve, this will come here. See, 36 is LCM. This is 1 into 2, or this one will come minus 1 into 1. Okay, so 1 by f. Okay, so f value will come when you solve. This is 1 into 36, or this is 36 centimeter. Okay, so focal length will be here, see, positive number, so this satisfy this one 36 centimeter. Now the other information here, CP is 72 centimeter because r equal to 2f. Okay, now the image distance is v, so this will come here like dotted line, or this is erected, so this will here to here 18 centimeter. So see, if we make a image formation, so guys, see how we will make the image formation. One ray of light will come parallel to principal axis from infinity. When it strike or incident, it will reflected like this, so it will pass through f virtually. Okay, means it seems that it is coming from f point. Okay, now the second ray of light, if you will see here, this one is here, so one ray of light here incident like this, reflected back and go to the center of curvature of this mirror, so this will be the point of intersection of these two. Okay, so see here, two rays of light are not cutting each other in actual, so image formation is virtual. Okay, so in such manner we solve the question based on concave and convex mirror, or you can say spherical mirror. So guys, hope how to solve the question based on spherical mirror clear to you. So guys, if you think this lecture is informative for you and others, so please like and share and subscribe.